Hello students, last class we have discussed about the law of chemical combinations and Dalton's atomic theory, etc. So now next topic is atomic mass and molecular mass of an element. So atomic mass is the mass consists in a nucleus of an atom. So it is defined as the mass exactly equal to 1 by 12 of the mass of one carbon 12 atom. This one carbon 12 means the carbon atom having atomic mass 12 AMU. AMU means atomic mass unit. So 1 AMU, that means atomic mass unit, is equal to 1.660 into 10 to the power minus 24 gram. Okay. So this is the process of calculating atomic mass of an atom. So suppose we have hydrogen and this is 1 AMU. We have known that 1 AMU is 1.660 to the minus 24 gram, and experimentally determined that the mass of one atom of hydrogen is this one. So in terms of atomic mass unit, mass of one atom of hydrogen and this one, and this 1.67 into this one divided by this one, this is the mass of one atom of hydrogen, and in terms of atomic mass unit. So similarly in oxygen atom, it is determined by this process. The mass of oxygen atom is calculated 16 gram, that means 15.99 gram, that means 16 gram or 16 AMU. So generally the atomic mass is the mass consists in a nucleus of an atom. So we have known that the nucleus, two types of particles are there, and proton and neutron. So mass of proton and the mass of neutron is the atomic mass of an atom. So atomic mass is equal to number of proton plus number of neutron, and generally atomic mass is the double of atomic number of an element. Okay. So in some cases, some element have different atomic masses. So for example, in carbon there are three different atomic masses, that is 10, 12 and 14. So these are the atomic masses and these are the atomic numbers of carbon atom. The atomic numbers of carbon atom is 6. So this one, and there are three different atomic masses, that is 10, 12 and 14. To calculate the average atomic mass of the carbon atom, this process is this one. So this is 10, 12 and 14. These are the atomic masses divided by 3. There are three different atomic masses of carbon atom. So the equal to 12. So we have taken the atomic mass, average atomic mass of carbon atom is 12. So these are called isotopes of carbon atom. Isotopes means having elements having same atomic number but different mass number. These are called isotopes of carbon. Similarly, in case of chlorine atom, there are two numbers of atomic masses, that is 35 and 36, but their atomic number is same, 17. So these are also isotopes, and to calculate the average atomic mass of chlorine atom, this is the process: 35 plus 36 divided by 2. There are two types of isotopes, so divided by 2 and equal 35.5. So we have taken 35.5 as the average atomic mass of chlorine atom. Similarly, these are the isotopes of hydrogen. These are the atomic number 111, and these are the atomic masses of hydrogen. This is the hydrogen having atomic mass 1, and this is the hydrogen having atomic mass 2, and this is the hydrogen having atomic mass 3. This is denoted as prosium or hydrogen, or this is denoted as deuterium, capital D, and this is denoted as capital T or tritium. Okay, and these are the isotopes of hydrogen. and this is due to the presence of different numbers of neutrons. See this one, atomic mass is equal to number of proton plus number of neutron. So in case of fast hydrogen, the atomic mass of 1, so number of proton is the atomic number of the hydrogen. So this one atomic number 1 and the number of neutrons. So in case of the fast hydrogen, the number of neutron is 0. Okay, but in the second case, the atomic mass is 2 and the proton number of proton, that means atomic number is 1 and number of neutron is 1. In the third case, atomic mass is 3 and number of proton is also 1 and number of neutron is 2. So isotopes arises due to the presence of different numbers of neutron in the nucleus of an atom. Okay, so next topic is molecular mass. So molecular mass is the summation of atomic mass consists in the atom of a compound. Okay, so HCl, this is the molecule, HCl molecule. So to calculate the molecular mass of HCl, so atomic mass of HCl, that is 1, and atomic mass of fluorine, this is 35.5. So molecular mass of HCl is 1 plus 35.5, that means 36.5. This is a molecular mass unit. Okay, in case of water, so there are two numbers of hydrogen, so 2 into 1. 1 is the atomic mass of hydrogen and 2 is the two numbers of hydrogen plus O. Oxygen, the atomic mass of oxygen is 16. So 2 plus 16, that means 18. So 18U is the molecular mass of water. Similarly, there are two numbers of oxygen atom. So 16 into 2, that means 32U. And in case of nitrogen, atomic mass of one nitrogen is 14. There are two nitrogen atoms, so 14 into 2, that means 28U. In case of H2SO4, there are two number of hydrogen atom and one atomic mass of one hydrogen atom is 1. 2 into 1 plus atomic mass of sulfur is 32, or atomic mass of oxygen is 16 and number of oxygen atom is 4. That means 2 plus 32 plus 16 into 4, 64. So this one 98U. So this is the process of calculating molecular mass of a compound. So the next topic is formula mass. We have discussed the molecular mass about the molecules, and this is the formula mass about the ionic compound. So in case of covalent compound, we have found the molecular mass of this compound HCl, H2SO4, O2, etc. So but in case of an ionic compound, we have found the formula mass. So the formula mass of NaCl, this is the atomic mass of Na and plus the atomic mass of Cl. So in case of ionic compound, there are no covalent bond between sodium and fluorine. This is a crystal lattice of sodium chloride crystal. So in case of crystal structure, no molecular formula is observed. So this is the crystal of sodium chloride crystal, and so in case of there are crystal system present in this molecule. So in case of ionic molecule, formula mass is observed. Actually the formula mass and molecular mass, the calculation of formula mass and molecular mass is same. So in case of formula mass, in case of sodium chloride, so the atomic mass of sodium is 23 and the atomic mass of chlorine is 35.5. So formula mass of sodium chloride is 58.5 U. The next is gram molecular mass. So when molecular mass unit is expressed in gram unit, so this is called gram molecular mass. When the HCl, this is the molecular mass of HCl is what? 1 plus 35.5. So this is 36.5. When this is expressed as G or gram, so this is called gram molecular mass. Similarly, the molecular mass of H2SO4 is 98 U or 98 AMU. So when it is expressed in gram molecular mass, then this is written as 98 gram. Okay. Similarly, oxygen 32 gram. This is called gram molecular mass. And similarly, this is also when expressed in gram molecular mass. This is 58.5 gram. Okay. So the next topic is percentage composition of a molecule. So percentage composition of an element which is consist in a molecule is the how much amount of that element consists in this molecule. Okay. So suppose HCl is a molecule. There are two percentage composition we have to be calculated. Okay, H and Cl. So percentage composition of hydrogen in HCl molecule is what? The total mass of compound, mass of that element, that means hydrogen, into 100%. So when we put the atomic mass and molecular mass of this element, so for percentage composition of hydrogen, the mass of that element, that means hydrogen, mass of hydrogen in HCl is what? 1 gram. And total mass of compound means total mass of HCl, that means what? 1 plus 35.5. 1 plus 35.5, that means what? Into 100. So 1 divided by 36.5 into 100%. So when calculate this one, we have got the percentage composition of hydrogen in HCl molecule. Okay. So next step, there are two elements contained in this molecule. One is hydrogen and other is fluorine molecule. So in case of Cl, mass of that element, that means Cl, and total mass of the compound. So total mass of the compound is what? 36.5. That means 1 plus 35.5 gram. So total mass of the compound is 36.5, and mass of that element, that means Cl, this is 35.5 into 100%. So when calculate this one, we will got the percentage composition of Cl. Okay. So similarly, in case of H2SO4, there are three types of elements. This means hydrogen, sulfur, and oxygen. Okay. But total mass of H2SO4 is what? 2 into 1 plus, for sulfur this is 32, or for oxygen 16 into 4. That means 2 plus 32, 16 into 4, this is 64. So this is 98 gram. This is the total mass of H2SO4. So percentage composition, there are three types of element: hydrogen, sulfur, and oxygen. The first one, for hydrogen, percentage composition is what? Mass of hydrogen, that means 2 divided by total mass of the compound, this is 98 gram into 100%. This is the percentage composition of hydrogen. When we calculate this one, we'll got this percentage. Okay. So for next one, for sulfur, mass of sulfur is what? 32, and total mass of the compound is 98. So this is the percentage composition of sulfur. And similarly for oxygen, a mass of oxygen in H2SO4 is what? 16 into 4, basically this is 64. So 64 by 98, 98 is the total mass of the compound into 100. So when we calculate this one, we will get the percentage composition of oxygen, not sulfur. Okay, these are about the percentage composition of an element. Okay, go through this video lecture and don't skip the video. Watch properly from beginning to end. Thank you.